It is generally unsafe to install or remove bus plugs while the bus is energized. However, if necessary for maintenance, stringent safety measures and appropriate personal protective equipment, or PPE, are crucial. The required PPE depends on the situation, but at a minimum, a hard hat, safety glasses, insulated gloves, insulated coveralls, and rubber boots must be worn. Ensure the area around the bus is free of obstacles and potential hazards. Safety procedures include using a non-conductive tool for plug removal or installation. Stand on a non-conductive surface, avoid touching the bus or energized components, and remain aware of your surroundings. If uncomfortable or lacking proper PPE, consult a qualified electrician. Detailed safety protocols are paramount when dealing with energized electrical systems to mitigate risks and ensure personnel safety. A bus plug, also sometimes spelled bus plug, is an electrical component used to connect electrical devices or equipment to a busway or bus duct system. A bus duct is a prefabricated electrical distribution system consisting of a series of interconnected bus bars enclosed in a protective housing. Bus ducts are used to distribute power efficiently and safely over long distances within a building or facility. Bus plugs provide a convenient and flexible way to tap into the power distributed by the bus duct system. Bus plugs typically consist of a housing that encloses electrical contacts and a mechanism for connecting to the bus bars within the bus duct. They may also include features such as circuit breakers, fuses, or disconnect switches to provide overcurrent protection and isolation for the connected equipment. Bus plugs are available in various sizes and configurations to accommodate different current ratings, voltage levels, and connection requirements. They are commonly used in industrial, commercial, and institutional settings to power machinery, equipment, lighting, and other electrical loads. Installing or removing bus plugs on an energized bus duct system can be hazardous due to the risk of electrical shock, arc flash, and other electrical hazards. Therefore, it is essential to follow strict safety procedures and wear appropriate personal protective equipment, or PPE, to minimize the risk of injury or equipment damage. Before attempting to install or remove a bus plug on an energized system, it is crucial to perform a thorough risk assessment to identify potential hazards and determine the appropriate safety precautions. This assessment should consider factors such as the voltage and current levels of the system, the condition of the equipment, the environmental conditions, and the experience and training of the personnel involved. Based on the risk assessment, develop a detailed work plan that outlines the steps involved in the task, the required PPE, the tools and equipment needed, and any specific safety procedures or precautions. This plan should be communicated to all personnel involved in the task, and everyone should be familiar with its contents before work begins. Ensure that all personnel involved in the task are properly trained and qualified to work on energized electrical systems. This training should cover topics such as electrical safety, arc flash hazards, PPE requirements, lockout-tagout procedures, and emergency response procedures. Only qualified electricians or trained personnel who have demonstrated competency in performing the task should be allowed to install or remove bus plugs on energized systems. Before starting work, inspect the bus plug and bus duct system for any signs of damage, corrosion, or other defects. If any problems are found, do not proceed with the task until the issues have been resolved. Ensure that the bus plug is properly rated for the voltage and current levels of the bus duct system and that it is compatible with the bus bar configuration. Always energize the bus duct system before installing or removing bus plugs whenever possible. Lockout-tagout procedures should be followed to ensure that the system remains de-energized while work is being performed. This involves disconnecting the power supply to the bus duct system and locking out the circuit breaker or disconnect switch to prevent accidental re-energization. A tag should also be attached to the disconnect switch indicating that the system is being worked on and should not be re-energized. When working on or near energized electrical equipment, it is essential to wear appropriate personal protective equipment, or PPE, to protect against electrical shock, arc flash, and other hazards. The specific PPE required will vary depending on the voltage and current levels of the system and the nature of the work being performed. At a minimum, the following PPE should be worn when installing or removing bus plugs on energized systems. A hard hat provides head protection against falling objects or accidental bumps. Safety glasses or goggles provide eye protection against flying debris, sparks, or arc flash. Insulated gloves are essential for protecting the hands against electrical shock. The gloves should be made of rubber or other insulating material and should be rated for the voltage level of the system. Insulated coveralls or a flame-resistant suit provide body protection against arc flash and other thermal hazards. The coverall should be made of flame-resistant material and should cover the entire body, including the arms and legs. Rubber boots or shoes provide foot protection against electrical shock and other hazards. The boot should be made of non-conductive material and should have slip-resistant soles. In addition to the PPE listed above, other types of protective equipment may be required depending on the specific circumstances. For example, a face shield may be necessary to protect the face and neck from arc flash, or hearing protection may be needed to protect against noise hazards. Always use insulated tools and equipment when working on only energized electrical systems. Insulated tools are designed to prevent electrical current from flowing through the tool and into the user, reducing the risk of electrical shock. Make sure that all tools and equipment are in good condition and properly rated for the voltage level of the system. Never use damaged or defective tools, as they may not provide adequate protection. Maintain a safe working distance from energized parts and equipment. The safe working distance, also known as the approach distance, is the minimum distance that a person should maintain from an energized part to avoid the risk of electrical shock or arc flash. The safe working distance depends on the voltage level of the system and the type of work being performed. Refer to applicable safety standards and guidelines such as the National Electrical Code, or NEC, and the National Fire Protection Association, or NFPA, 70E for specific safe working distance requirement. Use barriers, barricades, and other physical safeguards to prevent accidental contact with energized parts and equipment. These safeguards can help to isolate the work area and prevent unauthorized personnel from entering the area. Make sure that the barriers and barricades are properly installed and maintained, and that they are clearly marked with warning signs. When installing or removing bus plugs on energized systems, always use proper lifting techniques to avoid strain or injury. Lift with your legs, not your back, and keep your back straight. Get help from another person if the bus plug is too heavy or bulky to lift safely on your own. Use mechanical lifting devices, such as hoists or cranes, when necessary. Be aware of your surroundings and watch out for potential hazards, such as slippery surfaces, overhead obstructions, or moving equipment. Keep the work area clean and organized, and remove any debris or clutter that could create a tripping hazard. Pay attention to what you are doing and avoid distractions, such as cell phones or conversations. If you are unsure about any aspect of the task, ask for help from a qualified electrician or supervisor. Before re-energizing the bus duct system, ensure that all tools, equipment, and personnel are clear of the area. Inspect the bus plug and bus duct system to make sure that everything is properly installed and connected. Verify that all safety devices, such as circuit breakers and disconnect switches, are in the correct position. Only re-energize the system after you have confirmed that it is safe to do so. After the task is completed, document the work that was performed, including any problems that were encountered and how they were resolved. Keep a record of all inspections, maintenance, and repairs performed on the bus duct system and bus plugs. This documentation will help to ensure that the system remains safe and reliable over time. If you are not comfortable performing the task, or if you do not have the appropriate PPE or training, it is best to contact a qualified electrician. Working on energized electrical systems can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Qualified electricians have the knowledge, skills, and experience to perform the task safely and effectively. They can also identify potential hazards and take steps to mitigate them. The National Electrical Code, specifically Article 368, covers busways. This article provides requirements for the installation, construction, and use of busways. Busways are defined as grounded metal enclosures containing factory-mounted, bare or insulated conductors which are commonly used for feeder and branch circuits. Article 368.4 covers the uses permitted for busways. It states that busways can be installed where exposed and visible, except as permitted in 368.4a. Busways can be installed behind panels if means of access are provided, and all the following conditions are met. Firstly, no joins are located behind the panels. Secondly, the busway is totally enclosed. Thirdly, the busway is not ventilated. And fourthly, the busway is protected against physical damage. Article 368.5 covers the uses not permitted for busways. It states that busways cannot be installed where subject to severe physical damage or corrosive fumes or vapors. Busways cannot be installed in hoistways or were subject to combustible dusts or flammable gases, unless specifically approved for such use. Article 368.17 covers overcurrent protection. Busways must be protected against overcurrent in accordance with their ampacity. Overcurrent protection devices must be readily accessible and located at the point where the busway receives its supply. Article 368.30 covers support. Busways must be securely supported at intervals not exceeding those specified in the manufacturer's instructions. Busways must be supported independently of the suspended ceiling. Article 368.56 covers reduction in ampacity size of busway. Overcurrent protection must comply with 240.4. The next article to consider is Article 100, which covers definitions. Ampacity is defined as the current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. Enclosure is defined as the case or housing of apparatus, or the fence or wall surrounding an installation to prevent personnel from accidentally contacting energized parts or to protect the equipment from physical damage. Equipment is defined as a general term including material, fittings, devices, appliances, luminaires, apparatus, and the like used as a part of, or in connection with, an electrical installation. Qualified person is defined as one who has skills and knowledge related to the construction and operation of the electrical equipment and installations and has received safety training to recognize and avoid the hazards involved. Another important section to review is Article 110, which covers requirements for electrical installations. Section 110.2 covers mechanical execution of work. Electrical equipment must be installed in a neat and workmanlike manner. Section 110.3 covers examination, identification, installation, and use of equipment. Equipment must be suitable for the intended purpose and must be installed and used in accordance with the manufacturer's instructions. Section 110.9 covers interrupting rating. Equipment intended to interrupt current at fault levels must have an interrupting rating sufficient for the nominal circuit voltage and the current that is available at the line terminals of the equipment. Section 110.12 covers enclosure. Electrical equipment must be installed in enclosures that provide adequate protection against physical damage and environmental conditions. Section 110.16 covers arc flash hazard warning. Electrical equipment that is likely to require examination, adjustment, servicing, or maintenance while energized must be field marked with a warning label indicating the arc flash hazard. The warning label must include the nominal system voltage, the arc flash boundary, and the personal protective equipment, or PPE, required. Section 110.26 covers spaces about electrical equipment. Sufficient access and working space must be provided around electrical equipment to permit safe operation and maintenance. The working space must be clear and unobstructed. Section 110.28 covers spread of fire or products of combustion. Electrical installations must be designed and installed to minimize the spread of fire or products of combustion. Openings around electrical penetrations must be sealed to prevent the passage of smoke, fire, and gases. These National Electrical Code, or NEC, articles and sections are relevant to the safe installation and removal of bus plugs while the bus is energized. However, the best practice is always to energize the bus before working on it. If that is not possible, then the procedures and personal protective equipment, or PPE, outlined above must be followed. In addition to the National Electrical Code, or NEC, another important standard to consider is NFPA 70E, Standard for Electrical Safety in the Workplace. NFPA 70E provides detailed guidance on how to protect workers from electrical hazards, including arc flash and electrical shock. NFPA 70E requires employers to perform a hazard assessment to identify potential electrical hazards in the workplace. The hazard assessment must include an evaluation of the likelihood of occurrence of an arc flash or electrical shock and the potential severity of injury. Based on the hazard assessment, employers must implement appropriate safety controls to protect workers from electrical hazards. Safety controls may include engineering controls, such as installing arc-resistant equipment or using remote racking systems, and administrative controls, such as developing and implementing safe work practices. NFPA 70E requires workers to use appropriate personal protective equipment, or PPE, when working on or near energized electrical equipment. The type of PPE required depends on the voltage level of the equipment and the potential for arc flash or electrical shock. NFPA 70E requires employers to provide training to workers on electrical safety. The training must cover topics such as arc flash hazards, electrical shock hazards, personal protective equipment, or PPE requirements, and safe work practices. NFPA 70E requires employers to establish an electrically safe work condition before allowing workers to perform work on or near energized electrical equipment. An electrically safe work condition is achieved when the equipment is de-energized and properly locked out and turned out. NFPA 70E includes tables that provide guidance on selecting the appropriate personal protective equipment, or PPE, for different electrical tasks. These tables take into account the voltage level of the equipment and the potential for arc flash or electrical shock. NFPA 70E provides guidance on how to calculate the arc flash boundary. The arc flash boundary is the distance from energized electrical equipment within which a person could receive a second-degree burn if an arc flash were to occur. NFPA 70E requires employers to develop and implement an emergency response plan to address electrical emergencies, such as arc flash incidents or electrical shock. The emergency response plan must include procedures for rescuing injured workers, providing first aid, and contacting emergency services. These are some of the key requirements of NFPA 70E that are relevant to the safe installation and removal of bus plugs while the bus is energized. It is important to consult the standard for complete and detailed information. Working on or near energized electrical equipment can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. If you are not comfortable performing the task, or if you do not have the appropriate personal protective equipment, or PPE, or training, it is best to contact a qualified electrician. The Occupational Safety and Health Administration, or OSHA, also has regulations that address electrical safety in the workplace. OSHA's electrical safety standards are found in 29 Code of Federal Regulations, or CFR, Part 1910 Subpart S. OSHA requires employers to protect employees from electrical hazards. This includes providing training, personal protective equipment, or PPE, and safe work practices. OSHA requires employers to perform a hazard assessment to identify potential electrical hazards in the workplace. The hazard assessment must include an evaluation of the likelihood of occurrence of an arc flash or electrical shock and the potential severity of injury. Based on the hazard assessment, employers must implement appropriate safety controls to protect workers from electrical hazards. Safety controls may include engineering controls, such as installing arc-resistant equipment or using remote racking systems, and administrative controls, such as developing and implementing safe work practices. OSHA requires workers to use appropriate personal protective equipment, or PPE, when working on or near energized electrical equipment. The type of PPE required depends on the voltage level of the equipment and the potential for arc flash or electrical shock. OSHA requires employers to provide training to workers on electrical safety. The training must cover topics such as arc flash hazards, electrical shock hazards, personal protective equipment or PPE requirements, and safe work practices. OSHA requires employers to establish an electrically safe work condition before allowing workers to perform work on or near energized electrical equipment. An electrically safe work condition is achieved when the equipment is de-energized and properly locked out and tagged out. OSHA has specific requirements for lockout-tagout procedures. Lockout-tagout procedures are used to ensure that equipment is de-energized and cannot be accidentally re-energized while work is being performed. OSHA has specific requirements for working on or near exposed energized parts. These requirements include maintaining a safe working distance from energized parts, using insulated tools and equipment, and wearing appropriate personal protective equipment, or PPE. OSHA has specific requirements for electrical safety-related work practices. These requirements include using qualified persons to perform electrical work, using safe work procedures, and providing adequate supervision. These are some of the key requirements of OSHA's electrical safety standards that are relevant to the safe installation and removal of bus plugs while the bus is energized. It is important to consult the regulations for complete and detailed information. Working on or near energized electrical equipment can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. If you are not comfortable performing the task, or if you do not have the appropriate personal protective equipment, or PPE, or training, it is best to contact a qualified electrician. Remember, safety is paramount when working with electrical systems.